In this lecture, I will discuss how to analyze and design a concrete beam in ETABS, and I also verify the analysis results with the book. So the book which I am following, that is the Structural Concrete Theory and Design by Nadeem. Okay, that is 7th edition. So here is the design problem. The simply supported beam shown in the figure 4.12, this is the figure, 10 feet from the left side and 20 feet from the right side, and the 2-point loads also acting of 16 kip and 7 kip, point dead load of 16 kip and point live load of 7 kip, and the UDL WD of dead load 2.8 kip per feet and the live load that is 1.6 kip per feet. We will again see in the calculations, that is the live. So here the simply supported beam shown in the figure 4.12 carries a uniform dead load 2.8 kip per feet including self weight. Means in this 2.88 kip per feet, the self weight of the beam is already included. In addition to the service live load, live UDL, that is 1.6 kip per feet, and also beam support concentrated dead load of 16 kip and a concentrated live load of 7 kip at 10 feet from the left support from A. So what we have to do in this example, determine the maximum factored moment and its location on the beam. Okay, previously in the classes we do the manual calculations like structural mechanics 1, structural mechanics 2. So in this we do the analysis of this beam with the help of software, and then we will go for a design. Then we have to also design this beam against the loading. Okay, against the loading, but here is a condition that you have to use the percentage of steel, that is 1.5%. we will not do the 1.5%. we will design the beam against the loading. Second, the beam width is 20 inch and FC prime for KSI mean 4000 psi, and the grade of steel, that is 60,000 psi. 1 kip is equal to 1000. So I will go into the ETABS. Here I will start from scratch, file, new model. Okay, here are 3 settings. One is use, save, user default setting. If I have saved my user any setting, then software will use that. Or if I done a design of a building like in the last month, then I can use the settings from that model, or I can start from scratch from 0 level. Here is the settings. So this example, that is in kip fit, so I will select US customary unit system, and steel section data bus, that is for steel section like I section, channel section, so that we are not doing. Similarly, steel design code, we only concerned in this example with the units and with the concrete design code. So we are selecting ACI 31814. I will hit OK. Okay, then the next step is we have to define the grid. Okay, so our beam, the total length of the beam, that is the 30 feet. So I will just make the grid like 2 in the x direction, 2 in the y direction, and the distance between the x grid just like the grid in the x and y direction. So I will put in the x direction 30 feet, and in the y direction I will put like 2 feet, because I am designing in this lecture only one beam. So this 30 feet will be enough spacing in the x direction. So here is the number of stories data, so only one story will be enough. Okay, I will select grid only and press OK. Okay, so here you can see that is a 3D view of the grid. You can see in the x direction there are 2 grid lines, 1 and 2. Similarly, in the y direction there are also 2 grid lines, 1 and 2, A and B. But in the x direction, the spacing that I have said, that is 30 feet. Here you can see. So now I will close this my one window so that I can zoom my figure here. So now I will go one by one. First of all, I will define the material properties. In the material, I will define the grade of steel and the grade of concrete. So our grade of concrete, that is already 4000 psi for KSI. I will define from scratch, add new material, United States concrete. So here already defined FC prime, and if you have a concrete strength 3500, so you can select user defined. Okay, then you can enter. So in this example, I will use as it is FC prime 4000 psi. I will name it FC prime equal to 4000 psi. Okay, you can check either this is the name, either 4000 is defined. You can see in the show material property design data here 4000 pound per square inch. Okay, now I will define again steel material. Our reinforcement in the language of this software, that is rebar. So I will go in the rebar, that is our steel, that is the ASTM code for the steel. So here I will select 60 grade, 60,000 psi. I will hit OK. I will name it FY equal to 60 KSI. Okay, this is just the name. You can set any value, so any name. So here let's see the design data. So here the design data, the minimum yield strength, that is 60,000 psi, and minimum tensile means ultimate strength, that is a 90,000 psi. So here is the expected yield strength. So normally when we test the rebar, so the expected yield strength comes greater than the yield strength. So that is expected yield strength and expected tensile strength, that is more than the that we take for the design. Okay, so our concrete material is also defined, steel material is also defined. So now let's see what is the section. Section is 20 inch by, so that is the total height is 30 inch, 3.5 inch plus 26.5 inch, that will be 30 inch. So I will go define section properties, frame section. Okay, so here I will add new property. Here I will select concrete beam. Okay, here I will put the dimensions of this section, that is beam 20 by 30 inch. Okay, so here I will put the dimension. Our depth is 30 inch and our width is 20 inch. Okay, so one more thing. So when we do the manual calculations in the books like Whitney equivalent depth, okay, so for that we use the crack section. Okay, for that purpose you have to go in the modifier, and in the moment value, moment of inertia about 2 axis, moment of inertia about 3 axis, here we will put 0.35. So why we put these values 0.35? Software do not take the section as a cracked. If we do not put these values, the software will take this section as it is, as uncracked. So we are putting 35%, means now this beam will be used as a crack section. Only the 35% of the concrete will be used and the rest of the concrete will be ignored due to the tension side. So I will hit OK. So now our concrete section is also defined. Here I will select our material property that I have defined. So here FC prime 4000 psi, and for the reinforcement. Okay, so now we are designing the beam. Okay, for the beam, and here is the cover of the concrete. So that is the cover of the concrete from the center, from the edge of, from the bottom to the centroid of this bar. So here you can see in this cover to longitudinal rebar group centroid. So that is 3.5 inch in this example. Normally that is 2.5 inch, but in this example, okay, so top bottom one is 3.5, top you can take as it is because simply spotted beam. So for the rebar material, for our longitudinal bar, that will be FY 60 grade, and for the confinement or the ties, that will be 60 grade, and then hit OK. So here your beam will be defined. Press OK. Okay, here is your beam section. Okay, now I will draw the beam. So how you can draw the beam? Here is the option, draw beam column. Here I will click draw beam. So in the left you are seeing properties of the object. Here I will select my object, like the material which I have defined, beam 30 by 20 by 30 inch. Okay, I will select. Here you can see the snapping is on. I will select the first point, or you can say any location, and click the end point. Okay, you are seeing I have drawn the 30 feet. Now I will hit enter, escape. In the classes we use the x and y axis, but in the ETABS the vertical axis is the z axis. So we have to move in the elevation, and we have to now open the grid 1. Okay, elevation, open grid 1, apply. Okay, you can see here the beam is defined from this location to this location. Okay, at story 1 level. So you can also draw at the base or at any level. Okay, now I will draw the support at this point and this point. Okay, so I will select this point and go to assign joint restraints that are called supports. So here are the different supports. Here is the roller support, hinge support, fixed support. So here I will select roller support. I have selected this point. I will click apply. Okay, here you can see the roller support. Again I will click this point and click hinge support and click apply. Okay, now both supports have been defined. Now I have defined this thing. So in this ETABS there is one more thing, that is the load pattern. In the load pattern, here is a self weight multiplier. What is that? Here we define in the load patterns dead load, live load, wind load, earthquake load. Lot of types of loads are present. So here is the only the self weight multiplier 1 comes with the dead, and for all the loads that the self weight multiplier will remain 0. But in this example we will take the self weight multiplier 0, and software will not calculate the self weight because self weight is already calculated in this example. So that's why I have selected self weight multiplier 0, click modify. Okay. Now I will apply the loads one by one. I will click this beam and go to assign. Okay, here is the frame load, shell load. So that is our frame member. So I will click frame load and click distributed. Here in the distributed load, I will apply one by one. First dead, UDL dead, that is 2.8 kip per feet. UDL dead, here I will click 2.8 kip per feet. The type is dead. I will click apply. Here you can see dead. Now I will select live, and the live value is 1.6. Okay, I will click apply. Sorry, I have didn't selected the object. Select this object and click apply. Okay, so now you are not seeing the 2.8, but 2.8 is present. How you can see? You will right click this beam and go to the loads. Here you will see the dead load, that is 2.8 kip per feet, and live load, that is 1.6 kip per feet is present on this beam. Now I will apply the point load. I will go again select this beam, go to assign frame load, point load. In the point load, now I will first of all I apply dead point load, that is dead 16 kip and live 7 kip. So absolute distance from the one is relative, like 0, 25%, 75%, 100%. I will just put the distance, like at what distance I want to apply the load. I want to apply the load at distance 10 feet from the left support. How much? That is 16. Okay, apply. Here you will see the dead. Now I will apply the live load. Again the location is 10 feet, but the value is load 7 kip. Apply. sorry, I didn't select the object. Apply. Okay, so now you can see by right clicking on the beam, all loads are present. UDL load, UDL load, point load, UDL load and point load, both in the dead and live category. Okay, now I will go define in the load combinations. Okay, in the load combination we have defined only two load patterns, dead and live. So software will automatically make two load combinations at default design combinations. What we are doing, concrete frame design, convert to user editable. Here you will see first combination, that is 1.4 dead. Second load combination is 1.2 dead plus 1.6 live. Okay, so okay, I will hit OK, or I can rename it like first load combination is 1.4 dead. Okay, second load combination is 1.2 dead plus 1.6 live. Okay, that is the name of second load combination. I will hit OK. Now before running the analysis, I will save my model, file, save as. Okay, so let's save at this location, beam design. Okay, open, write the name of this beam, beam design. Okay, now I have saved my model, applied the loading, defined the material property, defined the length of this beam. Okay, support conditions, all I have defined. Now I will click run analysis. Okay, here after running the analysis, it is showing displacement against dead in inches. Okay, now it is deformed shape. So how we can see the shear force and bending moment diagram for each case. Here you will go display force slash stress diagrams. Here frame slash pier slash forces. I will click this. What I want to see, I want to see the load, the shear force and bending moments against dead load, live load, or against load combination 1.4 dead. All things are variable. Okay, you can check at any point. I have selected first load combination and clicked apply. Okay, here what is showing the moment 3 3. So there are different things, moment 2 2, moment 3 3, shear 2 2, shear 3 3. I will discuss later, but for simplification, for the shear you will check shear 2 2, and for moment you will check moment 3 3. So for checking the shear 2 2, apply shear force diagram. So let's come to the point. What did author in this example? Author used the load combination 1.2 dead plus 1.6 live. So let's go and see the shear force and bending moment diagram against 1.2 dead plus 1.6 live. Apply. Okay, so here you are seeing only the shear force. Similarly, you can see the moment diagram. Okay, and you can get the values at any location on this beam when you hover your mouse on this beam. Now to see the shear force and bending moment diagram simultaneously, at same time right click on this beam, right click. Okay, here you will see the shear force and bending moment diagram. Okay, and you can move your cursor and you can check the shear force and bending moment forces, and again also you can check the deformations. Okay, here. So now we have to check in this example at what location. At 10 feet, I will enter 10 feet, enter, and check the values. Okay, and in this example, the values of the shear at 10 feet, that is 49.82. Here you can see 49.8. Okay, and second, the moment value at location at 10 feet, that is 793.7. So here that is 794.6. Why this is difference? Because the author has downread of many values, so that's why there is difference in the decimals, but the answer are much accurate in this ETABS software. So now we have seen the shear force and bending moment diagram, and again you can check for other combinations, load cases against dead load, against live load. Okay, and For other things you can also check. So now I have analyzed this structure, shear force and bending moment diagrams I got. Now I will go for design. Here in the design, go for concrete frame design, and here you will select design combinations. Here we have defined two load combinations. Okay, so both are okay, design combinations. Now I will go for design. Here is the option start design / check. Okay, here software had designed this beam, and what is showing, that is the longitudinal reinforcement. So you can see the detailed reports. So first of all, I will show the both longitudinal reinforcement. For checking the shear reinforcement, display design info, shear reinforcement, apply. Now that is the shear reinforcement at 3 locations. Okay, so how to interpret these results I will discuss in the later lectures. Okay, so that's all for designing the beams in the ETABS. Further, last thing, you can get also detailed reports. Just right click and click summary. Here that will tell what is the beam section, what is the load combination that is governing for the criteria, what is the Fy, what are the factors, what is the design moment against the software has designed, what is the shear. Okay, so for further shear reinforcement, flexure reinforcement details are present. So that's all for today's lecture. Have a nice day.